where we specialize in building UAVs. So first, a little about me. My education, I got my bachelor's of science in aerospace engineering at UCSD and my master's at San Diego State. I actually got a job straight out of undergrad and was able to take advantage of paid school by my company. And so that's one of the perks of being a STEM professional is that many companies will pay for your master's. So I've been doing that. So my first job out of undergrad was working as an Air Force civilian working on the CP-22. I was a test and evaluation electronic warfare systems engineer. And essentially what that was is writing test plans and test reports and making sure that the aircraft did what people said that it was supposed to do, right? Did it meet the requirements? Is response time does it meet the requirements? So then I came back to San Diego and worked for the Navy as a Navy civilian. I worked on FAT and Hornets and Super Hornets in the second level maintenance department. I worked in structures and landing gear. And some of the highlights of working on Hornets and Super Hornets was the service life extension. The aircraft was originally designed to last for 6,000 flight hours. And oftentimes things don't work out and they need the aircraft for longer periods of time than they were originally designed. So it's the job of many engineers to go through bit by bit what the aircraft sees in its lifetime, can it be simplified, where are the suspected failures going to occur, and how do we remediate it before it becomes a failure that risks the lives of pilots. I've also been involved in some accident investigations and also engineering investigations where if there's a failure that occurs multiple times, we spend resources to investigate what caused it to fail so that we can prevent it in the future. So currently I work at General Atomics and I kind of work primarily on the Pred B. And at General Atomics I work on requirements analysis. I'm also in the landing gear design group. I've also had some abilities to work in some test plans and test reports, and also participate in sustainment and maintenance. And I think the biggest part that I wanted to stress here is that as an engineer, you have the ability to work in a lot of different aspects. When I was in college, and even maybe before that, I thought an engineer only did design, but the highest cost is actually in the maintenance department. So the acquisition life cycle is requirements analysis to design, to development, to testing, maintenance, and end of life. And so all aspects of these of this life cycle has engineers that support it and refine the design. So some advice for students to be successful in the STEM field. I would highly encourage students to get some hands-on experience. So at the high school level, that's participating in competitions and engineering clubs, even just taking something apart or fixing your car, welding and machining experience. All of those things are super valuable, not only in getting you exposure to what's out there, but also as far as getting that hands-on experience and makes you more, makes you more, and then also internships on campus and in private industry are also available for college students. I'd also encourage students to find something that inspires them. Sometimes, watching movies, can be very inspirational, and then also true heroes in real life can also be very inspirational. The reason why inspiration is so important is because engineering is really hard, and there are times when you ask the question, is this the right thing for me? And I think having the inspiration to kind of push you through those walls can be really helpful. And then also being open to relocation. I, straight out of college, went and worked at Edwards Air Force Base, and that's in the middle of the desert. And I'm not a desert person, but it was such an excellent experience to get out there, get my foot in the door, meet some great contacts, get some great experience, and be that much more valuable in applying for other jobs and coming back here to San Diego. So, and then last but not least, meeting professionals in the field. If you don't have connections, every engineering field has engineering professional societies. I am actually part of the American Institute of Aeronautics and Astronautics, and they have free membership for teachers. So if you go online, you sign up, they'll send you a packet of information, similar to what Jim was saying. They host meetings just like this, and you can meet professionals. But essentially, any engineering field has professional societies that are nonprofits that have this sort of stuff to help you get those connections. And that's Larry.
Thanks for the previous speakers for giving some really nice talks. My name is Larry Woolf. I'm a materials physicist at General Atomics. You're there long enough to make you a technical fellow or something high level. So I've been there 35 years, which is another kind of unusual thing for someone to be in one job that long. But I've had a whole bunch of different careers within being at General Atomics for that long. And it's actually common for someone, at least at my company, to be there that long. It's unusual in this day and age where lots of people move around a lot. So I think it says something for General Atomics. I'm also, 5 years ago, I became president of the General Atomics Sciences Education Foundation. So I do both these jobs, and I also am very involved in education work for my professional society, and I mostly interact with the American Physical Society, and I'll talk about all that. So my STEM journey, this is part A. I got my bachelor's in physics from Rutgers College in New Jersey, and I got my Ph.D. in physics right here from UCSD in 1982. I've been at GA ever since. Actually, I spent 2 years at a postdoc at Exxon, but I've been at General Atomics since '82. I've had a number of careers, mostly as, I've been a scientist, kind of an engineer, a technical lead, a program manager, an engineering manager. So lots of different sort of roles within the company of developing products. And I've always been involved in the design, the development, fabrication of advanced materials of all sorts of different types. For space power, for defense applications, from thin film coatings to larger things. But it's always been a materials physics development related activity. Even though I do that, I'm involved with lots of different types of people. I'm involved with all the different engineers that work at a company like General Atomics, electrical, mechanical, systems, materials, antenna, quality engineers. And I also work with a lot of people that aren't technical and scientific and engineering, like technicians who actually run the machines that make stuff that I design for them. Financial people, legal, patent people, the business development folks, and the program managers who actually manage the programs that you're involved in. So not only do you work with technical people, you work with a lot of non-technical people, so it's good to have good people skills. One of the reasons I've been at GA for 35 years is, at least I think, I'm relatively easy to get along with. I don't have temper tantrums, I don't get crazy, I'm actually a rational person to deal with. And being actually just a normal, pleasant person is probably the key thing you can have if you want to have a long career somewhere. If you're a jerk, nobody wants to work with you. So, people who you want to be a role model for your students, and you want your students to understand that being an adaptable, nice, cooperative person is really probably the key attribute that they can do, that they can gain from their school. And I will say that physics, my background, a little bit unusual to be at a company, but there are many physicists. It actually provides, it's kind of like the liberal arts of the sciences, and it provides a really good background to do anything. So as a physicist, I'm partial to physics. This is what General Atomics does in whole. Kathy talked a little bit about aeronautical systems, and we're the largest manufacturer of unmanned airplanes in the world. So we make unmanned airplanes. You may have heard of Predator, it's in the news a lot. We also have a whole history. The company really started out as a nuclear energy company, developing the trigger reactor, which is an ultra-safe reactor. One of the ways you operate this reactor is you pull out all the control rods, which normally would cause a meltdown in a normal reactor. This reactor was designed by some of the early pioneers in atomic energy to be inherently safe. So if you pull out the control rods, that's one way to run the reactor. It makes it pulse. It turns it on, then it automatically turns itself off. So it's a really brilliant design done by the Enrico Fermi type guys who were there at the beginning, who actually contributed to this design at General Atomics. We also have a National Fusion Facility at General Atomics. Maybe some of you have taken the fusion tours there, which I'll talk about in a little. We also make components. Part of the company that I'm in, which is the mission systems part of General Atomics Aeronautical Systems. The aircraft systems part makes the airplanes. The mission systems part makes all the missions that the airplane flies, or provides mission capability. And so that's the part of the company that I'm in. There's also a part of the company called Electromagnetic Systems that makes electromagnetic launch systems for aircraft, aircraft carriers. I don't know if you know, the aircraft carriers are launched with these big steam generators that create a huge amount of pressure and then push off the airplane. The next generation of aircraft carrier, which is just coming online, is going to be electromagnetically launched. So very risky for the Navy. Imagine designing your next $10 billion aircraft carrier, and the Admiral is on the line to say, we're not going to have any steam generators in it. We're going to trust this General Atomics electromagnetic propulsion system to launch these aircraft. And if you're wrong, you've now got a $10 billion white elephant that's going to become like a helicopter platform. So you can imagine there's a lot of risk reduction that was done by the people that developed this. So it's been a very successful program, and General Atomics is now the provider of that system for the next 3 aircraft carriers that are being built or are nearly, one I think is nearly done. One is in the process and one is in the future. So advice for students interested in STEM. What do industry employers and hiring experts expect of STEM graduates? I was involved in a project for the past 2 years, and our charter with the American Physical Society, I was one of 10 people in a task force, and our goal was to determine what skills and knowledge should undergraduate physics majors have when they graduate to be prepared for the diverse set of careers available to physics majors that they actually pursue. So I spent 2 years with a team of 9 other people to try to figure this out. And one of the roles that I played a major role in was actually, we got like 35 different reports from all sorts of different avenues: the National Academy of Sciences, think tanks, economic development groups, hiring experts. And what I did is I put together a summary of all these reports. So if so all the words you heard from these previous speakers were all true, and I completely agree with them. They're consistent with this. But if you kind of want to get a sense, if you want to spend 1 hour and try to get a great overview, well, not great, but it's a good overview, maybe great, of what students should know when they are prepared for STEM degrees. This document will give you, you'll be able to review this document in about an hour, because what I did is I took every single report that I got, which is probably total about 2,000 pages, and I distilled each report into about a half page of the essence of that report, half page to a page. So if you want to see what many different perspectives, what STEM students should know, this report actually has it. So it's on I made a copy of it, it's on my desk. It's also right here, and if you don't really have time to write this down, if you just type in Phys 21, capital P, Phys 21, and just put that into Google, it'll take you to the page where this is at. So if you really want to know, if you want to have a really nice and unique summary of these skills and knowledge, it's all contained in here. I also, a number of years ago, wrote up, I thought about why have I been successful, at least why do I still have a job at GA, and I came up with a 15-point guide to success that I thought distilled the essence of how you could really be successful at a company. So I have that here as well, which you'll be able to get from from this document when it's posted. But two of the items I had on there, the 15, is one is, always learn. Never stop learning. Continually expand the depth and breadth of your knowledge. And the other thing is, never be satisfied. Always be uncomfortable. You should never be happy with the way you are now. Always be uncomfortable with what you know, because there's always more to learn and there's more that you should be learning at all times. So this is maybe a little bit unusual to say stay uncomfortable. I think it's a key to success to never be complacent about your skills, because then you become outdated quite rapidly. Other things. This is me personally. I think there's a lot of ways people get inspired. I love reading, and there is so much amazing literature out there now, especially I think, in terms of books that are just wonderful reads for you to be inspired and learn an awful lot from a lot and get a whole different perspective on things. I'm a big fan of Richard Feynman. Maybe you know about him. Famous physicist, won the Nobel Prize. Was quite a character. In many, many ways. Stephen Jay Gould, evolutionary biologist, who was this incredible person who could put together stories that involve history and religion and architecture, baseball, why we don't have 400 hitters anymore, and convert that and tell you how that impacts evolutionary biology. Just amazing connection. So I love him. There's a whole bunch of essays also. Here he wrote, I don't know, 14, 15 books. I spent a year and a half and I read every one of his books. That's how much I was enthralled with this guy. Just a great writer. Davis Sobel, for the women and the female, they're a great writer. I mean, there's a lot of great women writers now too. Davis Sobel wrote Longitude, Galileo's Daughter. Just wrote a book called The Glass Universe, which I haven't read, but I've heard about it. It's about all the women at the Harvard Smithsonian who took these glass plates and really revolutionized astronomy and so the evolution of stars. Life's Matrix, a really interesting book by Philip Ball. And all the books by Malcolm Gladwell. He's a bestseller writer. He's written lots of things. He's a great writer as well. I just finished reading The Invention of Nature, which is really how ecology and the whole thinking about the world as a system started. This is a book about Alexander Humboldt, who was the most famous scientist of the 18th century, who you've never heard of, and I'd never heard of before I read the book. He was the most famous scientist in the world for like 50 years, and most of us never heard of him. And then, Silent Spring, I read it when I was a teenager, and it really impacted me about good writing and just about, she pretty much started the ecology, the environmental movement single-handedly. So there's a role model for women if you ever wanted one. Opportunities for your students. Kathy talked about this great program that's at GA and at many other companies where they do pay, once you get hired there, they do pay for your graduate education. Also, in the sciences, if you are a graduate student, which people think, oh, I go to school, I'm in another school, and how could I afford graduate school? You typically are paid to be a graduate student in the sciences. So students should be aware of that. Your tuition is typically waived. You become a teaching assistant or a research assistant. You basically get paid to go to graduate school and obtain your Ph.D. So students should not be put off by that, by this big, long time it's going to take. If they're really interested in the sciences, at most major research universities, you get paid to go to graduate school. Not a lot. I got paid a grand total of $3,000 a year when I was a grad student. So you make a sort of subsistence wage, but if you don't like buying anything, you're in great shape. Also, there's lots of programs out there aimed at assisting underrepresented groups in obtaining graduate degrees. I'm particularly knowledgeable about the American Physical Society, which is the National Physics Organization, and they have something called the APS Bridge Program to assist underrepresented groups in getting PhDs. In terms of resources and opportunities, there's a program that as a foundation president, I started in 2010, which says if you're a GA employee and you go into a K-12 classroom, you can buy up to $500 worth of stuff. All you have to do is tell me what you're going to do in that classroom and talk about your career, help the student do something actively in the classroom. And you can get reimbursed for buying $500 for that particular teacher or classroom. So this is a bottoms-up approach of trying to incentivize employees at General Atomics to go into K-12 classrooms and make a difference and show people what an engineer looks like. Well, we've had about 200 people participate in this so far. There's many education resources I've been doing. For many years I did education workshops. I have one person here who's attended one a long time ago, but there's a lot of education modules and presentations about all sorts of things at the Company Foundation website. And the Fusion, the General Atomics Fusion group, has a huge amount of resources on their website as well. And also, you can tour the GA Fusion facility with your classroom for free. Generally, the buses are paid for. You kids can go in and get a tour of the GA D3D National Fusion Facility, which is one of the largest fusion reactors in the United States. Encourage students to follow their interests. My interest in education really made me really, it just added so much to my life, you know, that when I started doing education stuff. I got drawn into this and really it became kind of a second career for me. There's many possible education roles for industrial scientists and engineers. That's really not what I'm talking to here, but maybe I just wanted to make people aware of it. There's a lot of things you can do as an industrial scientist in education. So if you have a student who says, well, I really want to go into industry, but I really like education, there's a way to do both. It may not be normal or typical, but you know, there's one proof of principle, right? I've done many different things, and as many others, but you know, my own personal case that I can point to where you can get involved in lots of different stuff. And this is just an example of some of the things I've been involved in different activities, all the way from elementary school to graduate school in physics, where I've been involved in different panels, different groups, developing curriculum, reviewing programs. There's lots of different things that one can do in education and industry and make an impact. And I think one of the things that I think I bring to the table is I have a knowledge of science education, but I'm also someone who works in industry, so I kind of have a sense of both worlds. And I've been doing this now, education stuff, for 25 years. And I've been in industry for 35 years, and so I understand both worlds pretty well, and I'm able to provide my input into the educational system to provide that perspective. So fun things can happen. Notice this poster right here is one of the ones right there. It actually got on the Big Bang Theory. So, and occasionally even stranger things will happen to you that you know you didn't know.